Imagine standing in a massive forest at midnight. It's completely pitch black. To survive the cold, you huddle close to a single roaring campfire. That's exactly what it's like to live in our solar system. Space is dark and cold. The central fire keeping our planetary neighborhood warm is a massive star we call the Sun. The Sun contains over 99% of all matter here. Because it is so heavy, its gravity acts as an invisible tether, pulling the tiny planets into stable, continuous loops and preventing them from drifting into the dark. Inside the core, crushed atoms release a constant flood of heat and light. This process has kept the Sun burning for nearly 5 billion years. Since this fire provides our only real warmth, the character of every planet is shaped by exactly how much of that heat reaches it. The first worlds we find are the ones sitting closest to the flames. This is the inner circle: Mercury, Venus, Earth, and Mars. Because these planets are so close to the Sun, the intense heat completely blasted away any lightweight gases and ice. What remained were dense, solid spheres made of rock and metal. You can see the effects of that solar baking on Venus. It's a world of extreme heat, covered in deep geological scars and jagged terrain. Earth sits at a very specific distance within this hot neighborhood. It's temperate enough for liquid water to cover the surface, allowing life to thrive. We have even begun to step out onto this solid ground ourselves, leaving the first human footprints preserved in the dusty soil of our moon. Mars is the final world in this rocky group. It's a barren, dusty place that marks the end of the solid neighborhood. In this inner circle, the Sun's intensity was simply too high for gases to settle, leaving behind a neighborhood defined by solid ground. To move further out, we have to cross a boundary line. The asteroid belt is a ring of floating rocks that separates the warm inner planets from the freezing outer dark. As we travel past these rocks, the Sun begins to look like a distant, tiny dot. The light fades, and the temperature drops rapidly. Here we find the giant planets hiding in the shadows: Jupiter, Saturn, Uranus, and Neptune. Because these worlds are so far from the Sun's heat, they were able to hold on to lightweight materials. They aren't solid rock. They are massive spheres made of thick layers of swirling gas and ice. These deep atmospheres are incredibly chaotic. Jupiter, the largest giant, is covered in violent cloud bands and raging storms that have lasted for centuries. Saturn is defined by the massive rings of ice and rock that circle its atmosphere, cutting a sharp silhouette against the dark. At the very edge of the system sits Neptune. It is a blue, icy world dominated by storms and deep cold. Seeing these two halves together shows how distance is the ultimate architect of our system. While the heat nearby creates rocky worlds, the cold of the outer shadows allows gas and ice to grow into giants. When we look at the whole picture, we see a single, connected family, a central fire surrounded by its rocky inner circle and its icy outer giants. But even this entire system is just a tiny spark in a much larger landscape. Our Sun is just one of billions of other stars inside the Milky Way galaxy. Each of those stars is another potential campfire with the chance for its own worlds to circle it. Despite how massive the galaxy is, this specific neighborhood of 8 planets is our unique home in the cosmos. Every world here tells a part of our history, and as we study them, the universe truly comes alive.